In this experiment, we are going to test the rate of change in a magnetic field and relate that to the voltage. So we're getting asked this question: what is the relationship between the rate of change of the magnetic field in a coil and the induced voltage? So we've kind of talked a little bit about this magnetic field being induced by a changing magnetic field inducing a voltage. So we see this image here. We've played around with that Faraday's law simulation. We've looked at this, and what we're trying to ask about in this relationship here is making this voltage by changing the B field, right? And so we're going to change the B field, or we could change the time needed to change the B field. So really what we're looking at is how fast the magnet go and the electricity that gets made. Where if we double the speed of the magnet, we should be getting double the electricity. So what I mean by that, what we're going to be doing is we're going to be taking this magnet and dealing with just a single set of coils, and we're not changing the coil, but what we're doing is we're going to be changing the speed at which this magnet goes through this coil. Where if I take this coil and I take the magnet and I move it through slowly, I get a small voltage. But if I move it through quickly, I get a bigger voltage. And I can move it much quicker by doing something like this, and I get a much bigger voltage. So we can see about how fast this magnet goes. That's going to be telling us a relationship. So in our assignment, I'm asking over here, what happens when the magnet goes faster? So you should be able to say something on that. I want you to give me a procedure, just like how we had with the number of turns versus the voltage. Same thing. But now what we're doing is we're going to be using some data here where we're dropping these magnets through. And as we drop them from different heights, we get different velocities as they go through that through the coil. Now, the problem here with this is we're dropping them from different heights. So one height we're going to be dropping from here, and then it's going to fall and speed up and go through the coil. Another one, we're going to go from a higher height. And so the problem here is that the magnetic flux is also going to be different in some of these. So we're changing the magnetic flux, but for our experiment, what we're going to say is that the magnetic flux is being held constant, and what we're going to change is just the time needed to change that magnetic field. So in other words, all you got to do is say something on here, not relating the number of turns, but rather now the speed of that magnet, and you're going to relate then that speed with these given velocities to that average induced voltage. And you're going to be able to find that average induced voltage and get the average by making your copy of this Google Sheet. So when you have the copy of your Google Sheet open up, we're going to skip that 1.3 meters per second. That was really hard to read, and I wasn't able to get some good data with that. But if I go at the 1.5 meters per second, I could, let's say this is the data. I'm not saying it is. Actually, this is not the data. If I had 2, 3, and 2, then what I'm going to have here is this is going to pop up as the average of our data set. So it's going to pop up the average of this data set, and as it does that, then it's going to pop up the average of our data. And let's say I had over here 3, 4, and 3, and then over here I had 5, 4, and 5. Then I just want to get these numbers up over here. So then I have a 2.33, I have a 3.33, and a 4.67. And then I have my chart where I copy my chart, and I'm going to input my chart down here, and I'm going to Control V, and paste it unlinked. So that way I have my graph. Now, this is not the actual data. I just made up some numbers. What you're going to need to do is you're going to need to watch some of these videos in here. This is where we got the data. So you're going to have to get the data from within here. So once you open these up, and then you're going to be able to click play, then you're going to be able to see the data that comes about. So you're going to need to watch these in order to get the data to put into here. Then we're going to be able to come down here, and then we're going to be able to state this relationship. So you should see something. Should see our relationship where we're saying the change in this magnetic field divided by the time needed to change the magnetic field, it's going to relate us back to this voltage. So in other words, we're going to make this electricity by making the magnet go faster. Faster magnet, more electricity. If we want less electricity, we make magnet go slower. So I know it sounds like silly when you say it like that, but that's really kind of just the way it is. So I want you to try to state that relationship, try to use your data up here, use your graphical relationship as well as your raw empirical data as well to state what it is that you got for your relationship. So once you have that, you're good for your laboratory experiments.